So today we'll talk text processing and regular expressions. So, ouch. You do or do not like regular? They are absolutely amazing. And if you get regular expressions, then you can unlock the world of text processing. All right, let's. So we're gonna load up Stringer. That's the library we're gonna use for our regular expression processing. Here, let me get all of this. Let's close this. Okay, so library Stringer. Okay. And you can always look up this thing for help on Stringer and whatnot. Okay. So this is how Stringer functions work. Stringer, Hadley Wickham made it, so it's good stuff. Okay, we got string detect, string locate, string extract, string match, and string split. Okay. And also, there's going to be string detect all, string locate all, string extract all, string match all, and string split all, okay? So basically, all of these things are in the form of string, comma, pattern. And what this means is you give the function the argument string, okay? So you have a text string, and then you also give it a pattern to use for the matching or the searching or whatever it is, okay? So string detect, you give it a string, okay? Let's say you give it the text of the Constitution of the United States, and then you say, you give it a pattern, like we the people, and then we ask, does that show up in the text of the Constitution? And then string detect would say true, right? But then if you say, I don't know, what's something that's not going to be mentioned in the Constitution of the United States, you put something in there, and then it will not, it will return false, right? String locate will return the first position of a pattern. So if we say string locate in text of the Constitution, and we give it the pattern, we the people, then it should say, that's at the beginning, yeah? It's probably location 1, unless, well, maybe location like 10 if you say like, article, whatever, right? No, preamble is the preamble, not article 1, preamble. So, okay, and then string extract, it's going to pull out the text, right, that matches. So if you give it a literal pattern, like we the people, then string extract will pull out we the people. But later on, we will show you meta characters, which basically mean, find letters or find numbers, and it will pull out the thing that does that, okay? And then beyond string extract, there's string match. And sometimes with a pattern, you can say, I want you to find this pattern, except I don't want the entire pattern. I only want a portion of it. And you would use string match for the to pull out the portion of the pattern there, okay? We also have a string split, which will split the string into pieces and return a list. But that's how we will go. Okay, let's try this out. Oh, I guess my picture didn't load. I don't know if this is worth looking it up. XKCD on regular expressions.
What is the pattern? What is breaking apart?
Yes. I'll have to check that out. All right. Okay. So here's a comic for your enjoyment. Maybe it's stupid. So this elaborate scenario has not yet happened in my life, but that's okay. It may or may not happen in your life, but knowing regular expressions is certainly a helpful tool to have in your arsenal. Okay. Oh, what is this? This comic, Regex. You try to match one group but not the other. Okay. /m. Oh, and you try to do it in. Okay. All right. Okay, this is stupid. All right. Matches Star Wars subtitles but not Star Trek. Oh, okay. What are the Star Wars subtitles? Really? So. Okay. All right. Never mind. Okay. T or N. All right. Well, I'll have to play with that now. Okay. Text. All right. So let's say we have this vector. The quick brown fox jumps over the lazy dog. It's a vector. We've got, how many words is this? 1, 2, 3, 4, 5, 6, 7, 8, 9 words. And let's say, so we give it, the strings. We give it 9 strings, a vector of 9 strings, and we say, do you detect this pattern? Do you detect Q-U-I-C-K? All right, and it will say, no, except for the second one, yes, it detected Q-U-I-C-K, right? Over here, we can just say, all right, do you detect the letter O? And it says, nope, nope, yes in brown, and yes in fox, and no, but yes in over, and no, no, yes in dog. Okay, that makes sense. All right, what about, do you detect the pattern, the letters R-O-W, and that only is true for the word brown here, okay? So this is just matching literal letters, okay? That's fine. Simple matching, you give it letters and it just, if it detects that, and this would work with any of these other functions, detect, locate, extract, match. So if I did locate here, it would return a 1, whereas over here for the O, it would return 3 and 2 and 1 and 2 for those ones where it located the thing, okay. Yes, it is case sensitive. All of these things I think are better illustrated with the actual demonstration. Okay, let me pull this up here. See, it shows up in my thing here. All right. All right, so we got string detect. There's O, and then let's say I did locate instead. Okay, so here it pulls back, it says it found 3 and so on and so forth. But if I say OW, okay, then it says it found it only in the word brown, okay? That's string locate. And then string extract, it will just pull out the part that matched, which in this case, it's just going to pull, it will say, okay, didn't match, and then, oh, okay, you wanted me to pull out the O, I pulled out the O here, okay? Which at this point, success. All right, I've done it. Okay, the meta characters, this is what makes regular expressions really powerful, okay, is all of these things. So you want to remember these. I mean, you'll eventually get a hold of handle on these things. All right. So these are all meta characters, and they have special meanings here. Okay. So here I've got ABC square bracket DEF, and we're asking, do you match this square bracket? And it's a meta character, so the regular expression says, no, I'm not going to try to match this meta character, okay? And so if you do want to match a literal square bracket, you have to say, you know what, I'm talking about a literal square bracket, and you have to escape it using a slash, okay? And so, but however, because the slash itself is a meta character, you have to escape the slash. So you have to say, do you find this literal square bracket? You have to say double backslash square bracket. And then R says, okay, now I'm looking for the literal square bracket and not the meaning the meta character meaning of square bracket. Okay. Is that all right? So here we're trying to, in this string, do we have this literal square bracket? And the answer here is yes. Okay. So these are just special characters, and we will use them. Okay. All right. So that's the double thing. All right. So this is kind of our first set of meta characters that we'll cover are called anchors. And this basically means when you search for the pattern, okay, when you search for this pattern that we're going to give you, we only want you to search at the beginning of the string or the end of the string or at what we consider a word boundary. Okay, a word boundary is, in the English language, a word boundary is a space, right? This is how you know one word has started and another word, that distinguishes words from each other, right? And that's how we know when we see the word baseball as without a space, we know we're talking about the concept of the game baseball. And if you see the word base space ball, then we know we've got two different nouns there and things like that. Okay, those are word boundaries, and so basically we use these as anchors here. Okay, so how does this work? We've got the caret for the start of the string and the $ for the end of the string. Or if you can't remember that, you can say /A, because that's the start of the alphabet, and /Z for the end. This means the start of the string or the end of the string. Sometimes when you'll see things like this and it throws you off because you think you're trying to match the letter A, but you're not. It's a /A, which means start of the string. It's the anchor. Okay, so here we are given, the text is just one string here. It's not a vector of strings. And so what we're telling R to do is we're saying search for the character THE, but only match it at the start of the string, okay? And so because at the start of our string we have THE, it matches it. And so when we run it through string replace, it replaces the THE with a dash. All right, so this was a successful match, right? But over here, if we say search for the letters DOG, okay, so if I did, here, let me pull this up here. So if this is my text, the quick brown fox jumps over the lazy dog, and I say string replace this, okay, if I didn't put in the caret there, and I just have dog, then it will find the word dog here, and it will replace it with a dash, okay, because that's what string replace does. It says I'm going to look for the string, look through the string. If I find this match DOG, I'm going to replace it here. But if I put the caret in here, now it will only match dog if DOG appears at the beginning of the string, which it does not, okay? And so here it finds no match. So string detect here would return false, right? String detect, string detect would say, no, I don't have that thing, okay? The caret is the same thing as /A, so this also, /A, okay? So this again doesn't work, but /A THE will, all right? Okay, same thing with the $sign. The $sign says, will you find DOG at the end of the string? And yes, it does. Will you find THE at the end of the string? No, it does not. Okay, is this all right? So the only difference between the ones where it did find it and didn't find it is that a word gets replaced with a dash when it successfully finds it. Yes?
When you say like the start of the string, does it mean like only the first word? Or like what is the cutoff?
Yeah, it means at the start of the string. So let me just, if I take, so what is my text? Text is this, and if I if we take this, and if I put a space in front of this, then it's no longer... Okay, so now my text, this is my string, and so there's a space here. And so if I do string replace, and we say, so if I just have THE here, then it works. It goes space dash space here. But if I say, okay, it has to be at the start of the string, this will no longer, this will no longer have a match because the caret is, THE is not at the start of the string, okay? So if I want this to work, I have to do start of the string space THE, and then we have a match. So start of the string means start of the string. Yeah, exactly. Okay. Is that okay? All right, and same with the end of the string. If you got extra trailing space, it's going to say that's not the end of the string. It's looking, basically, within the system, it says, you know, this is the start and this is the end of the string, and it's looking for those things. Okay. Oh, okay, and then here's the same thing, except we're using, instead of the caret and the dollar sign, you can use /A /Z to kind of say, all right, this is how we matched and not. Okay, those serve as anchors. And then here we have //B. Okay, now a lot of times in regular expressions, the little letter version is the thing, and then the capital letter version is not that thing. Okay, so you can kind of remember complements by using the lowercase versus the capital case. So you've got little b /b for word boundary /B for not a word boundary. All right. So what is a word boundary? Okay. So over here we've got again, the text is the quick brown fox jumps over the lazy dog. Here we're going to say we want the letters JUMPS, but it's got to be between word boundaries. Okay. So only replace jumps if here, like in this case, it's the entire word jumps, right? Here we don't have a match because we said //BJ, so this will match the front part, but because I have //B over here, we say the P has to appear at the word boundary, and that doesn't match because we don't have any word that has a P at the word boundary. So so right here, we have that, okay? If I got rid of //B, what would the resulting text say? So I've got //B. Would it find a match? Yes, and what would it would replace the match with a dash, so we would have the quick brown fox -S over the lazy dog, right? Oops. Right? So it has matched where it has jumps. It did successfully find J, you know, a word boundary, and then JUMP, and then so it replaces that with a dash, and then we have the S left over. Okay. Over here, capital B means not a word boundary. So this means look for the letters UMP as long as U is not at the start of a word, and as long as P is not at the end of the word. Okay. So if I take this string here and I throw in, we'll call this text, and we'll have the quick brown fox jumps over the lazy dog. I need to have jumps over this, and then I'll throw in the word ump, okay, just for fun. Okay, this will replace the UMP in jumps, but will not replace the UMP in just the word ump, because UMP, they are at word boundaries. Is this okay? Where here, let me do another example. So if I said word boundary here, will this replace the UMP here? Yes. Will it replace the UMP in jumps?
Yes.
Right. Okay. And what about this? Just UMP. UMP will replace both. It will replace the UMP here and then the UMP. Wait, it didn't work. What happened? Oh, because I only have replaced the first one. Okay, replace all. There we go. Okay. Scaring myself as well. Okay. Okay, and then and over here with capital B, JUMP, capital B. So this means not a word boundary and not a word boundary. This will not match anything because J appears at the word boundary. Okay, meaning it's at the start of a word or something. All right. Is this word boundary concept? Is that okay? Does that make sense? Yeah. Okay, now we have special characters for character classes, right? So we got little s for white space. This is both breaking and non-breaking spaces. Do you guys know what a non-breaking space is? Okay, so in so if we were to write an essay, right? I don't know when the last time you guys had to write an essay was, but you know, we became stats majors, so we wouldn't have to write essays. Let's say, you know, basically, you know, as you type something, and let me just magnify this, okay? As you type something into Word, you know, the computer forms breaks between words. Okay, and that's because each of these spaces are called breaking spaces, meaning when it reaches the end of the line and it says, oh, I can't fit this word here, I'm going to move the word onto the next thing, right? Now, you might have something like the word Los Angeles, or the city of the name Los Angeles, okay? Now, we're okay, like if we see this, this would not bother us. But someone might say, Los Angeles is an important concept, and you cannot separate the LOS, the Los, from the Angeles. And we must keep these together, right? So how do we basically keep everything together and have a space here? You have to insert a non-breaking space. And I don't know, what's the non-breaking space in Word? All right, how do we do this? Oh, man. What is it, Control-Shift space? Okay. So if I can do Control-Shift space, and what this does is it prevents Word from allowing the Los and the Angeles to be separated, okay, between words. So normally, if I write Los and Angeles, it would put Angeles over here, but right here, I have a non-breaking space. It looks the same as a regular old space, but it's a non-breaking space. And so Word will not separate these two things. Apparently, Control-Shift space will do it. And if you do the secret command, like the symbols, then you can distinguish between a regular old space and a non-breaking space. Okay, so that's a non-breaking space. And so a lot of times, they appear on websites, and you can't really tell. Okay, they look exactly the same, but they both count as white space characters, and so so that's a non-breaking space. Okay, anyway, you want to match non-breaking, you want to match white space, whether it's breaking or non-breaking. You use /s, and you want anything that's not white space, you do capital S. Okay, little d is for digits 0 through 9. Capital D is for anything that's not that. And little w is for a word character, which is basically all the letters, digits, and underscores. and then capital W is a non-word character. So pretty much like username stuff, right? Like if you had to make a username, those are word characters. Okay, and then so here, let me just kind of show you what this would match. So if we have the text is the quick brown fox jumps over the lazy dog ump. We can do string replace and we'll do text, and I'll look for I'll just look for a Q and a // W. Okay, so this means search for the letter Q, and then anything that follows the Q, just this is going to be a single character. So what will this replace? Oh yeah, it does need to be in quotation marks. Thank you for that. Okay, so this will just replace the QU here. Okay, and so we'll be left with the ick brown dog. And if I do all, it's still that's what we would get. Okay, if I do U / W, what would we replace? So I'm saying replace all, and we would get, it would replace the UM here, the UI over here, and the UM over here. So it's looking for a U and then anything that counts as a word here. Okay. Okay, if I do E and a / S, this is going to replace E and white space. So here it replaces the E between and the space here, and then it also gets rid of the E and the space between lazy there. Okay, so this is E and a white space character / S there. Okay. We can also give it ranges of characters. Okay. Dot means this is any character except a new line character. A square bracket ABC means the letters A, B, or C. Square bracket with a caret ABC means not the letters ABC. And A through Q would be any lowercase character from there to there. And then over here is capital letters. And here we have digits, okay? So if I say we're going to replace anything, we'll do a THE. What is this going to do? So it'll replace all the T's, all the H's, and all the E's with a dash, okay? So it's going to replace H and E, and this E here, and THE like this. Okay, so this is replace all. If I had string replace, it's only going to replace the first match. So it'll replace the H and the first the. Okay, this is what we have here. So I got string replace all. And it just sees these letters, THE, as kind of a bag of letters. So this pattern and this pattern are exactly equivalent in that they, it just says, do I match anything, a T, an H, or an E? And then, and yes, it matches a T, an H, or an E. Okay. All right, is that okay? Yes. It matches just the letters. So it says, so what this says, this is the pattern, okay? And this is establishing a single thing. So do you match an E, an H, or a T? Every time you find a match of this thing, replace it with a dash. So it's coming along, it goes through this, it says the quick brown fox, and it says H. Well, capital T, does that match? No, so I'm gonna leave it. H, does that match here? Yes, I'm gonna replace it with a dash. I go to the E, does that match? Yes, I replace it with a dash. Space, does that match? No. Q, no. U, it goes through each thing and it says, ah, I found a match here in between the E for over. that matches this pattern, this entire pattern, it matches, so it's going to replace it with a dash. So it just goes through the thing element-wise. So, what if I want to, for this, okay, I could say, all right, you know what? I want to replace the letter O followed by the letters X or G, okay? So what will this return? It's going to be the quick brown F jumps over the lazy D dash, okay? So the quick brown, this now looks like we're swearing or something, all right? So this is what we have, right? This is different from if I just did //W, what would the change be between this and this? We would replace the OV in over. Okay? So it would be the quick, and the OW in brown, yeah. Okay, so we would get this because that's a match, this is a match, this is a match, and this is a match. Okay, so it's just one letter at a time there. Do these examples make sense here? What's happening? So here with the square brackets, we're saying that this effectively represents one character, but it will match any one of these characters. And then so again, with the X and the G, that's what we get. And then if I put the caret in here, it will do the other ones. It will do not the OX and OG, but it will get the brown and the over. Okay, and then we have quantifiers. So all of these here so far, when we established a class, such as the S, the D, the W, or some class of characters here, we've only been saying do one. But now we can establish a quantifier. Quantifiers say 0 or more with a star, plus is 1 or more, question mark is 0 or 1, and then this is exactly 3, 3 or more, or 3, 4, or 5, or a range. Okay, so let's just kind of mess around with this. All right, so if I did, so keep it. Let's take a look at this. So we've got string replace all O//W. So this got the OW in brown, the OX in fox, the OV in over, and the OG in dog. Okay, if I do //W plus, what this will mean is match the letter O, and then any character, any word character that comes after O, and the plus means 1 or more. So that will take out not just the OW in brown, but it would take out OWN in brown, okay? Or actually, let me think. I think it's going to just replace everything. Oh, wait, no. //W is word character, so it will not get to the space. Okay, so it'll reach the space and it'll say that's not a word character, and it will stop. Okay, so it will replace OWN in brown. For over, it replaces the whole thing. It matches the O and it replaces everything after that. The all 1 or more letter characters after that, and then it gets the dog and whatnot there. Yes. So the dot is 0 or more. So let me just see if we don't have any words that end in O. Let me we will fix that. Let's just take text and how can I add to my string here? All right, we'll say Coolio. All right, so we've got this now, and so if I did, instead of a //W, and I did a dot plus, okay, well here, let me just show you what //W plus here. would do. Okay, so this is what. Oh, I'm sorry. It gets the O here. All right. Because I used Coolio. All right. We'll just. No, that's something. All right. All right. I don't know what we're doing. All right. Okay. So this doesn't get this here, right? Because it says you got to find the O and then a character after there. Okay. So it's not going to get that. But if I did a star, it says 0 or more, and so it will match the O here. And even though it doesn't have any words after it, it says, well, you said 0 or more is fine. Okay, and so that's allowed. Okay, a question mark here is 0 or 1. So again, now we only replace one at a time. So it'll get the OW and the OV, but it also replaces the O in Celio because it says match 0 or 1. Okay.
So on the previous slide, when we had the other table, what was the top?
Oh, any character except a new line. Okay. So yeah. So the so if I did dot plus here, then it says the quick brown, and it finds the O, and then it says any character after that, boom, everything matches. Okay, with a dot. So the dot is really dangerous because it'll match everything. So whether it's a I don't know, space or not space, it will match. Okay. So and then dot star, yeah, we'll match all of that. Okay. Also same. So that's the star. The dot is any character, and then you establish characters here. Okay. There's this concept of greedy versus ungreedy matching. Okay. So here's like an extract from some kind of HTML thing. Okay. And we could say, all right, we want to match. So none of these are meta characters. The less than and greater than sign, those are not meta characters, so we don't have to escape them. And so if I do the div and the closing div tags, and I say dot star, this will match everything in between the opening and closing div tags. Okay. And so here, when we look at this, it will say, okay, oh, I found the opening div tag here. This match is right here, and then I find this thing back here. All right, and so the regular star behavior is it's going to try to match as much as it possibly can. Okay, and that's called greedy matching. It's going to match this beginning part right here and go all the way as far as it can, and it goes all the way to the end of the line. If I put in a question mark, this will be non-greedy matching, and it will start here, and it will go only to it will end as soon as it can. So it says, I find the match here, and I find the closing match here, and I'm going to stop. And so that's ungreedy matching. All right. Here, let me see if I can illustrate this maybe over here. So we'll take a look at our text. Okay. So if I say string replace all, and I do O dot star O, and I do a dash, what will that do? This will take out everything from brown to Celio because it's going to go all the way from this O all the way to this O. Okay? So that's what it does. If I put in a question mark here, how far will it go? It will go from the O in brown to the O in fox. And then because I did replace all, then it says, okay, I found O to O here, and then it get from O and over to the O in dog. Okay, so because I said string replace all, so it found another kind of match there. So it goes and does that. Okay, so that's ungreedy. Whereas if you leave it greedy, then it will try to do as much as it possibly can. Okay, here we've got something called groups, right? So we might be interested, group together parts for modification or capture, okay? And we use string match or string match all. So here, you might say, we won't do replace, but we'll do string match, okay? And with string match all, this is what we have, and it says, okay, when you have O dot star O, this is what I've matched. Now you might just be interested in just the part in some aspect here. You can put parentheses here, and this forms what is called a capture group, okay? And it says, okay, this is the pattern I matched, this is the part I've captured from WN to, this is the part that's inside here. If I make it ungreedy, then it will say, all right, we found from brown fox to, this is what I've extracted, the OWN, the WNF, and then over the lazy dog, and it extracts this part. Okay, so again, if we take a look at the original text, this is what it's doing. The parentheses establish kind of capture groups, and it says, did you match this pattern? Yes. Except maybe you are not interested in the entire pattern. You only want some aspect of it, okay? So for example, let's say you were looking at people's phone numbers, right? And you're only interested in, or maybe, okay, maybe not, maybe that's not good. Okay. All right. Let's say we have ask for everybody's email address, right? So we can establish some kind of pattern for an email address, right? It would probably be like //w, and then the @, and then you know, some kind of thing, and then a literal dot, and then some more letters, right? So this would kind of match an email address, right? And maybe you were just curious, like, how many are Gmail versus, you know, UCLA.edu versus Yahoo, or what other email service somebody might use. And in that case, you're not interested in the entire string. You don't actually care for what the person's username is, or whatever else might be. And here you're just interested in the part that comes after the @ sign, right? Followed by dot, I mean, you can just say .com, okay? And this will be, you know, anybody with a .com email address, so we won't get UCLA.edu's. But this part will basically say, I'm only interested in the part that comes between the @ sign and the .com. Okay? The parentheses here indicate the capture group, saying I only want the stuff between the @ sign and the .com. This is what we want, and then it will pull that out when you do a string match all. Yes.
When you did string match all before, it gives you like with the things on the side of the parentheses plus like the things without the
So it gives you the entire pattern that matched. Okay, so the first part is the same as string extract all. So string extract will be the entire pattern that matched. So I found own from brown fox to over the lazy dog. So it finds the match there. But then the match part, so this is the part, the entire pattern that matches, and this is just the aspect that we are interested in. Okay? And perhaps maybe we just do dot, and I can say I just want 2 characters, and then we want everything after that, okay? Oops, not string extract. So what will this do? This will just do, so here, this is the entire pattern. So it's going, basically still going from O to O, but here, because I put a dot and a 2, this will only just take the 2 letters after the first O that it matches here, okay? So now this is what we get, and then we still want everything else, so that's what we have there. Okay, and you can have multiple capture groups, which is neat and whatnot. Okay, so here, this is the pattern A through J, and here we want to pull out, match the pattern A, B, C, D, and it matches that. And then as far as the extraction part, we just put that in the capture group, and we're able to do that, okay? And if we have multiple capture groups established by multiple sets of parentheses, it will pull that out when we do, string match or string match all. Here's an example with phone numbers, right? So here we have some text, Apple, and this, and here is, if you have a form that says enter your phone number, somebody might be overambitious and says, I've got 2 phone numbers, I'm really important, and I'm going to list them both in the thing, and maybe we want to be able to pull that out. Here, phone pattern will kind of look for, this is established as the first capture group, followed by another capture group and another capture group, and this probably could have written this a little bit better. And these ones will match. And with string extract, it just matches the first pattern. But if you did string extract all, it will say, you know what, I matched it here and here in the last case. In the last case, so it returns us a list here where it matched all of those things. Yes?
Okay, so firstly, when on the line it says phone pattern,
Yeah.
why do you have
So this means, because if we think of area codes, no one's area code starts with a 0 or a 1, right? Because that's kind of how the phones companies used to do that. So this means the first digit has to be between 2 through 9, and then you can have 2 more digits between 0 and 9, and we want 2 of those, right? So this is any digit 2 through 9, another digit, and another digit. I could have done a /D too to say, so I'll have a total of 3. Yes?
So say there were area codes that had 0, 1 from the beginning, would you just make that 2 and then 3 up there? At the end, in those braces.
Well, you would get rid of this first part,
Right.
okay? And then you would change this to a 3, yeah. Exactly, which is kind of what we have here, although it's true, I don't think any prefixes start with a 0 or 1 either. So we probably could have used the same pattern there, okay? Okay, and that's what we have. Here, this is a good site, regexer.com. This allows you to just kind of play around with things and see, like, can I match the thing that I'm looking for? So definitely check out this to test out your regular expressions. All right, have a great weekend, you guys. We'll see you on Monday.